Let's see how you're doing on these. We'll put the timer on again. Last time you were averaging about 10 seconds per. Keep it under 10, you'll be doing fine.
80.
Good. This one gives you trouble.
Putting it into 28. I don't know how many times 4 goes into 28.
7. And I don't know of any other way to teach you other than to just, you got to memorize it. 7 times 4 is 28. Therefore, 4 goes into 28 7 times. And this is minus, because we have a minus into a plus.
1. 7.
Good.
Man, I'm getting all the easy ones. 0. 2. Minus 100. Wait, no, just 100. Minus 7. 7 or minus, yeah, 7.
Now, when you add 2 negatives, you get a negative. Remember, that's the one difference between multiplying and adding. When you multiply 2 negatives, you get a positive. But if you add 2 negatives, you get a negative.
10. 15.
Okay. I noticed that it doesn't put up the hard ones. Let me give you some of the harder ones. The harder ones being the 6, 7, and 8s. I think you got the 9s figured out, correct?
Yeah.
Okay, let's do the 6 tables.
Oh, 6 times 3 would be, that would be 18, right?
Huh?
Yeah.
I'll tell you when that's not right.
30.
Right. Whenever you multiply a number by 5, the answer is going to end in either 0 or 5, always. And take half of 6, that's how you get that. What's 7 times 5?
7 times 5, that would be 35.
Right. Notice that ends in a 5. In other words, if you multiply an odd number times 5, it's going to end in a 5. Multiply an even number times 5, just take half the even number. In other words, 8 times 5, take half of 8, you get 4. And of course, it's 40, not 4. Okay. Now, these are the ones that give most people the most trouble right here.
48.
Good.
56.
Good.
That would be 21.
Good. All right. Let's go on. Let's talk more radicals. Okay. Now, there's 2 theorems involving radicals that are the most important to memorize. One is if I have the square root of 2 numbers multiplied together, that's the same as the square root of the first number times the square root of the second. In other words, the square root of 2 times 3 is the square root of 2 times the square root of 3. which makes the square root of 2 times the square root of 3 equal to what?
2 times 3, or the square root of 2 times 3?
Well, the square root of 2 times the square root of 3 is the same as this. Well, what's this? That's square root of 6.
Oh.
You with me?
Yeah.
Okay. The other rule is just the division part of it. The division is the same thing. If I take the square root of two numbers being divided, I can take the square root of the top number divided by the square root of the bottom number. So, if I want the square root of 20 over 2, what's that going to be?
It's going to be...
Just do this step only.
Okay. So, the square root of 20, that doesn't go in evenly.
That's okay, we'll simplify it later. What I'm trying to get you to learn is these two basic rules. So, it's equal to that. Very simple. Okay? Whatever this is, I can divide it in by like this. Okay, you with me?
Yep.
Okay, let me do some out of the book here. Multiplication.
So it would just be the square root of 8 times 2.
Well, give me that number.
16. Square root.
And what is the square root of 16?
4.
Yeah. So this equals the number 4. Even though both of these are irrational numbers. You can multiply two irrational numbers together and get a rational or a whole number. Hold on.
That would equal the square root of 27 divided by 3.
What is that number?
I want to say it's 6.
Okay, count up by sixes 3 times and see if you get 27. You go 6, 12, 18. So 3 times 6 is 18.
But 3 times 7 is just 1 over.
21. You're getting the idea on how to do these. If 3 times 7 is 21 and 3 times 8 is 24, must be 3 times 9. Notice those two numbers add to 9. That means it's divisible by 9. Well, if it's divisible by 9, 9 goes into it 3 times, then this must be the square root of 9, which is also a whole number 3. Alright, let's do some simplifications. Simplify this if it can be simplified. Remember, to simplify it, we need to factor it. In other words, what I'm looking at is the square root of some A times some B. So I'm going to factor it into the first factor times the second factor, like that. Well, what two numbers multiply to 27 where one of them is a perfect square number? Which is the perfect square number that is a factor of 27?
Wouldn't that be factor of 27?
I'm going to list the perfect square numbers over here. You don't need any more than that.
I don't even need 16.
You're right.
So the only one to do was 9.
Exactly. But that's what we're doing. Whenever we're trying to simplify this, is we're always looking for a factor that is one of these perfect squares. So, what is it? It's the square root of 9 times the square root of what?
3.
Can you simplify that?
The square root of 9 times 3, or 27. So, yeah.
No. When I say simplify, I mean, is there anything we can get rid of the radical sign on?
Oh, that would be 3.
Yeah. In other words, that's what it simplifies to, is 3 times root 3. You would never write that as an answer. You would always write it this way. But in order to simplify it, it involves this factoring process. And you'll discover one other thing. If I let you use a calculator, it would not help you. Because calculators don't factor numbers for you. In order to be able to factor a number, and you can see that we've done a lot over the last few weeks where we've had to factor numbers, whether it's part of a quadratic that's being factored or whether it's part of a radical that's being factored. You have to factor a lot. And the only way to really know how to factor is to know your multiplication tables by heart quickly. So let me give you another one. It's a little more difficult. Let me put the perfect square numbers up there.
Well, 25 would go into it 2 times, but not enough.
Not perfectly. It's got to go into it perfectly. Now, I could put the next one up, but because this is more than half of that, it can't possibly be right. So I don't even need to list 36 for this problem. But any of these 4 might be the answer. I don't know. Which one of those divides into 52? Evenly.
What about 16?
No, good guess, but it doesn't.
Okay.
But 4 does.
Yeah, because 9 can't.
No, 9 doesn't, because that doesn't add to 9.
We've already eliminated 16 and 25,
So 4 must be the thing. Now, what is 4 into 52 equal? Here, let me show you how to do it, because we haven't really talked about doing long division with 2 numbers. Okay? Divide 4 into the first number. What do you get?
1.
Multiply 1 times 4. Subtract. Bring down the 2. What's 4 into 12?
3, so 13.
13 is the answer that we're looking for. That's not the complete answer to the problem, but it's the answer to this. So now what's the final answer?
Equals 2 square root of 13.
You got it. Can square root of 13 be simplified? No, because not only does it not have a perfect square as a factor, but it's prime. So when you come across a prime number, you don't have to look for factors. There aren't any factors of prime numbers. Now let's talk about prime numbers while we're talking about it. A prime number is any number that can only be divided by 1 and itself. So 2 is a prime number. 3 is a prime number. 4 is not, because 4 can be divided by 2. 5 is a prime number. At this point, they're all odd, because if any even number can be divided by 2. So there aren't going to be any more even prime numbers. 7 is prime. 9 is not. It can be divided by 3. 10 is even, but 11 is prime. 13 is prime. 15 is not. 15 can be factored into 3 times 5. So, it's good to know prime numbers. You don't have to remember a list of them or anything, but it's good to know what it means to be prime. And once we recognize that's prime, we don't need to even try to factor it. You're never going to be able to factor a prime number. 101 is prime. So if I said square root of 101, guess what? That's simplified. That does not reduce. What is... You're familiar with this dot means multiplication, right?
Yeah.
Okay.
Well, if you took away the 2 or spaced it out, it would just be 7.
Okay, so now multiply the 2 times 7.
So 14.
That's the answer. In other words, whenever you're multiplying 3 numbers together, if I have A times B times C, I can multiply those together and then multiply that result by that if I want. Or I can multiply A times B together and then multiply the result by C.
Unless there was parentheses around 2.
Yes, exactly. Well, even then, it's still multiplication, parentheses is. But in this case, the easiest way to do the problem is to do those 2 first, giving you 7, and then 2 times 7 is 14. So. Remember we talked about this. How can I make that look more like a mathematician would want it to look? And what's wrong with it now?
Oh, right. You
It's called rationalizing the denominator.
have to...
Because right now, the denominator is irrational. And irrational in math doesn't mean crazy. You know, if a person is irrational, they're crazy. But if a number is irrational, it just means it cannot be written as a fraction. There's no way to write the square root of 2 as a fraction. So I have to rationalize it. Well, I can certainly rationalize the bottom by multiplying it by square root of 2. That's going to turn it into 2. But remember, I can only multiply a fraction by the number 1. So I got to do the top by square root of 2 also. Square root of 2 divided by square root of 2 is 1. So when I multiply this number by this number, I'm not changing its value because I'm only multiplying it by 1. What do I get?
You get, the square root of 2 divided by 1.
What's square root of 2 times square root of 2?
Is 1.
It's 2. So whatever the number is. Square root of 7 times square root of 7 was 7. Square root of 15 times square root of 15 is 15. Rationalize this for me.
So it would be square root of 3 divided by the square root of 3.
Remember what I'm doing. I'm attempting to turn the bottom into a whole number. So I'm never going to end up with square root of 3 at the bottom when I rationalize it. I'm going to end up with 3.
Oh, I thought you meant that one that you just wrote.
Oh, okay. I got you. Okay. Yeah, no, you're going to multiply it by that. And what you're going to find is that all of these are the same. You don't even have to do it. If I've got an answer like that, that's always going to be square root of 5 over 5. If I've got 1 over square root of 7, that's going to be square root of 7 over 7, and so forth. What if I have 3 over the square root of 5?
Wouldn't you do the same thing?
Which is? And what's the answer?
You mean for the answer? Then you would have the square. No, you'd have 3 times the square root of 5, and 5 on the bottom, right?
Very good.
Yay!
That's how you rationalize numbers. Okay, so now let's do, well, I'll go through my book here. What's that equal to?
That's equal to 9. Wait, no.
Let's do it in 2 steps. It's going to be the square root of 1 divided by the square root of 9, first of all, correct?
Yeah.
Okay, what's the square root of 1?
1.
What's the square root of 9?
3.
There's your answer, 1/3.
Oh, okay.
Okay, getting it now, I think?
Yeah.
What is the square root of 4 81sts?
So it'd be the square root of 4, that would be 2, and the square root of 81.
What's 8 and 1 add to?
9.
There's your answer.
Oh.
That's what the square root of 81. Remember that when you're looking at something that is divisible by 9, this number is always 1 less than what the 9 is multiplying by. In other words, if we multiply 9 times 7, the first digit is 6, 1 less than 7. I know the second digit has to add to 9, so it must be 3. Well, if I do 9 times 9, the first digit's got to be 8. The next digit has to be 1. What is the square root of 12 times the square root of 2? Well, what rule do we want to apply here? We want to apply one of those first 2 rules. In other words, we got the square root of A times the square root of B. That's going to be the square root of what?
24.
Right. Now, can that be simplified?
Yeah.
Because it's divisible by what?
4.
Yeah, so that's the same as the square root of 4 times the square root of 6. Notice that we just turned it around. In other words, we turned it into something where now we can get rid of one of those radical signs. So what's this equal to?
2 times the square root of 6.
Right. So this becomes that. Notice that neither one of these can be simplified. I can't simplify 6 because that's square root of 2 times square root of 3. And neither one of those is a perfect square. I can't simplify this because that's square root of 2 times square root of 5. neither one of those is a perfect square. But if we apply our first rule, what is it?
60.
Now, 60. Is 60 have any factors that are perfect squares?
I assume so.
4.
Yeah, 4.
A lot of numbers are divisible by 4. So when you're looking for factors of these numbers, it's not a bad idea to start at 4. Even if there's a bigger one, you're not going to get in trouble by starting with 4. You can always whittle it down. In other words, you can keep doing it if you need to. So this is the square root of 4 times the square root of what? Do it by long division, like I just showed you. Divide 4 into 60. What's this first number?
1.
Multiply 1 times 4. What goes here?
2.
Bring down the 0.
20.
What's 4 into 20?
5. So 15.
15 is the answer. Now, I've got it as the product of two numbers, one of which is a perfect square, so I can say, again, this thing that either one of these could be simplified on their own, but once I multiply them together, I can simplify. First step, always do the first step if you don't know where to begin. In other words, separate it into the division of two square roots rather than the square root of the division. So what's the first step?
3, or the square root of 3 divided by the square root of 16.
Okay,
And one of those, not irrational, so...
Well, what is this? First of all, see if you can reduce it immediately. In other words, is that a perfect square number? Yes. So I can replace it with 4. And now I'm good to go. I've got a rational denominator. That's all I need. And I don't have to do anything more. There's nothing more I can do to simplify that. All right. That's a good place to stop. We'll pick up next time with more stuff. Okay?
Okay.
All right, Garrett. Have a good weekend. Talk to you next time. Bye-bye.